And I do want to introduce that we do have a new ILR coordinator. Her name is Pam Krieger. She's not here right now, but she will be here by the end of the session. So you'll get to see her and meet her. I would like to welcome you and introduce our session for today. Take it away, Bob Bernstein.
And I would like to say a little bit about the series of habitat restoration. There's some, I think, some powerhouse speakers. We're lucky to get them. A number of the presentations are about correcting the mistakes that we have made in the past. So it's restoring things that have sometimes been altered by man and need some correcting. Because some of these, a lot of projects ignore what I would call externalities. What's the cost of converting a marsh to housing development or something? There is a cost that's always paid for by the public, not by the developers. So we have failed to recognize the ecosystem services provided by like wetlands and seagrass beds and springs. So that's what some of this course will be about. And wetlands are sort of the foster child of some of these habitats. You ditch them, you dike them, you drain them, and then you build on them. But they actually provide many valuable services, and Ron will talk to that. And Ron Brockmeyer is an environmental scientist 5 at the St. Johns River Water Management District. Prior to that, he was at Harbor Branch Oceanographic Institution working on fisheries and wetland research. And he came to the district in 1994, so he's been there for 30 years now. I will take only minor credit for this because I hired Ron. And Ron is responsible for all the wetland projects and restoring over 22,000 acres, some of it with really interesting equipment, big giant machines that walk on water, explosives, rotary ditching machines that throw the mud 50 feet to the side. He's currently the chair of the Northeast Florida Estuarine Research Team and had been the PI for a multi-agency wetlands research team for the Wetlands Initiative at Marin Island National Wildlife Refuge, where in the Indian River Lagoon system, that's where a lot of the wetlands are. So it's a pleasure to have Ron come and visit, and we'll show you what he has done with some of the wetlands. Ron.
There we go. Sorry about that. Um, today I'm going to talk a little bit about the projects that I've worked on and why we've done them. The title slide here, a lot of the impacts that have occurred to coastal wetland systems in Florida have been because of mosquitoes, and a lot of the other ones have been because of development. So that's sort of where we're going. This is a nice shot. This is probably 15 years old, but this is in Volusia County on Spruce Creek. The mangroves were just starting to get there at that point. So let's get started. Coastal wetlands. I use this term more than I use salt marsh or mangroves. In the area I work in, they switch back and forth based on the period between severe freezes. In the Indian River Lagoon, For example, on the east coast of Florida. The severe freeze that occurred in 1989 pushed mangroves from St. Johns County down toward Martin County, um, almost complete mortality. That's typical. That's how the northern boundary is controlled. Um, but the two components, salt marsh, basically herbaceous coastal wetlands, and mangroves, are what we're talking about today. Now, they do produce a few mosquitoes. Um, all of that little outline almost looks like a bird. Those are all mosquito larvae. That's like lots of mosquito larvae. And what typically happens is they lay their eggs on moist substrate. And then when a tide or a heavy rain comes in, they synchronously develop. So they all come off at one time. You get these just clouds of mosquitoes coming out of the wetlands. And then they proceed to bite people, which makes them relatively unpopular with the public. So, what kinds of things have we done or have been done to coastal wetlands by man? Some of these don't have a big component in the state of Florida. Um, in places where there's a lot of herbaceous marsh, they were used as grazing land. Um, to feed cattle, whatever. Um, they're also used in a subsistence sense for firewood or charcoal production in places around the world. Probably the biggest impact to them in the U.S. is for energy development. Louisiana has canals and ditches and pipelines running all over the place, cut through coastal wetland systems. Now, the last three are the ones that are prominent in Florida. And we'll cover those just to get an understanding of the kinds of things that are involved. So let's see if we can get. Yeah. That one. Okay. So all of this blue, dark blue, kind of royal blue color, this is the intracoastal waterway. And this is all the dredge material they took out of the intercoastal waterway. And they basically just dumped it on the adjacent wetlands. This is a stretch between like the mouth of the Tomoka River in northern Volusia County up to the southern end of the Matanzas River. So this is northern Volusia, almost all of Flagler County and into St. Johns County. Now, in these places where it was in the middle of a wetland, you end up with things that aren't supposed to be in the middle of a wetland. So you end up with a lot of terrestrial vegetation, cedars, oaks, but you also end up with Brazilian peppers. Depending on the latitude, you can get Australian pines. You can get all kinds of things that don't belong in a salt marsh. And they're there because of the elevation. They're out of the influence of the tide. One of the other things we used filling for was development. So over in this panel, this is from an 1870s navigational chart series. All of these parallel lines, that's wetland. This is a 1943 photograph. That same area has all been filled. This is actually military. It's like barracks. But this area hadn't been filled yet. This is just the little tab that they have gotten south of this little canal. Well, this is what it looks like more recently. This is the last piece of coastal wetland in Daytona. Basically, almost the entire shoreline's developed. This is South Daytona, Finger Canals, and this is the area that was filled previously. So we looked at wetlands as a resource, a place to build stuff, and it took care of the mosquitoes at the same time. Here's another example. This is in Indian River County. This is shall we say, high-end community. This is the moorings in Vero, and it used to be um, wetland. So sort of the lighter gray color is herbaceous, and the darker speckled is mangroves. So it's the same community that we see now um, in places that are undisturbed. Now, the last couple of things that we've done, well, I will mention there are a couple of places where they actually used filling like they would do for residential development to control mosquitoes, but it was only done for a very short period of time because it was not cost effective. The idea there is that you put enough fill material in to take it out of the intertidal zone, and then it doesn't breed mosquitoes anymore. But it was way too costly for them to uh, make a dent on the amount of wetlands there were by filling that way. Now, the first efforts to control mosquitoes in the early 1920s and 30s was ditching, but they were hand dug or in some cases dug with dynamite. Um, and they were fairly effective at controlling mosquitoes for a short period of time until the ends of the ditches sort of filled in by wave energy, and you ended up with sort of a long linear breeding habitat that periodically flooded and bred mosquitoes. Um, so in the late 40s and early 50s, we switched over. A lot of the mosquito control districts switched over to DDT, and it was really effective for a very short period of time until resistance developed. By the mid 50s, nobody was using DDT because it didn't work. So it became really important for them to figure out ways to control mosquitoes without the chemical controls that they had depended on because they were no longer working. One of the methods they came up with was this sort of ditching on steroids. This wasn't just, you know, a little hand ditch. So what they basically did is they took a drag line, an excavator, put it on a little barge, and then send it out into the marsh, and it basically ate its way through the marsh. And what you end up with is these parallel ditches with big spoil piles. So you took this, what would have been all marsh, and you end up with this series of ditches with big piles of spoil that are not at wetland elevation. They don't function as wetlands. The only wetlands in this system is this little strips that run down the middle, the pieces that are still at wetland elevation. So let's see. The other main control, and this is what the vast majority of the wetlands in the Indian River Lagoon system from Martin County, Volusia County sort of changes over, but up till Merritt Island to the Kennedy Space Center area was to build impoundments. Now, the ditching systems basically altered the hydrology so that mosquitoes couldn't get through their life history stages in the aquatic phase. So it drained the surface, or there was no surface for them to actually breed on. In impoundments, they basically built a dike around the wetland, and they used drag lines just like the ones. These are usually larger than the ones they used to do dragline ditch systems. And basically, they just excavated along the perimeter of the wetland, built a dike. Now, you might ask, how does that control mosquitoes? Um, if you cover the surface of that marsh with even an extremely thin film of water, salt marsh mosquitoes won't lay their eggs. If they don't lay their eggs, you can't get those big hatches where they cloud the water with strange shapes and emerge in huge clouds. So they built the impoundments and then either flooded them with artesian wells, trapped rainwater, had freshwater watersheds that filled them with water, or they pumped water in from the adjacent lagoon. And they basically would flood them in the summertime. Salt marsh mosquitoes, their development is temperature dependent. So the warmer it is, the shorter the period of time they are in their larval phases. So during the summertime, they go from hatch to emerging in 5, 6, 7, 8 days versus, 10 days, 2 weeks longer when it's cooler. So it shortens the period of time where things can feed on them in the water, and a lot more of them get to that emerging stage. So in the Indian River Lagoon, let's see, do I have that slide? Nope. Yeah, I do. They built impoundments around almost all of the salt marsh. All of the shoreline that had salt marsh pretty much had an impoundment around it until you get to the central portion of Mosquito Lagoon. Now, the reason they did this is because the tidal range in the Indian River Lagoon is so small that they were concerned that ditching would not be effective because it wouldn't inundate the surface and drain back off. In the Indian River Lagoon, the tide ranges in parts of it are, an inch. The celestial tide is dampened down to just, a very, very small amount. Seasonally, the water level changes almost a foot. In the fall, it's a foot higher than it is in either the spring or, let's say, July or August. So the period where mosquitoes bred were from June, when it started getting warm and started raining, until October, when the entire marshes would go underwater. But they built a lot, almost 40,000 acres in the Indian River Lagoon. And that's the vast majority of wetlands in the entire system. But in doing so, all of these impacts influence the other benefits that you get from coastal wetlands. These are not all of them. These are examples. So, fiddler crabs. They burrow little holes, but they also feed on organic matter on the marsh surface. They can get to extremely high densities. Everything eats them. They are a perfect forage organism for otters, raccoons, bobcats, fish, alligators, almost anything will eat them. And when their larvae are in the water, a lot of fish actually eat the larvae. So shorebirds love the really small sized fiddler crabs. But there are also snails, and there are also shrimp when there's an aquatic, when they're inundated. There's a lot of things that are tied to the plant production in that salt marsh. This guy is basically here to tell me to let you know about the organisms that come and go in that system. The otters, the birds that are not resident in those marsh systems, but they depend on them for food and shelter in some cases. Now, this is an FWC slide. No warranties here. So, this is just a little schematic. There are a whole suite of little bitty fish, nothing bigger than maybe 2 or 3 inches, that spend their entire life history in a salt marsh. So these guys are intimately tied to those coastal wetlands. And there's also a shrimp on there. Here's the fiddler crabs. These guys, if you go fishing, are the ones you're trying to catch. But These same guys, tarpon, redfish, snook, and mullet, sort of. I wouldn't eat them, but some people do. They also spend time in the marsh. They spend time in the marsh feeding on these guys. So as the water levels come in, and we talked about seasonal inundation, so these areas are completely flooded part of the year. This net production, so whatever is produced by the plants and the algae that grows on the surface of the mud, all of that production, primary production, is exported through not only these guys that come in. Mullet actually graze on the substrate. They'll actually eat the benthic algae that's on the surface of the marsh. These guys will eat all of those guys. Now, there was a study done at Merritt Island while we were working up there that tried to quantify how much fish biomass, fish living, organisms, the weight of fish that is produced in a salt marsh as resident fish. So we're not talking about the big guys that come in and graze and then head back out. So if you subtract everything that's been consumed and carried out already, the birds, the otters, whatever, all of the fish, and you look at just how much of those resident fish are left when those water levels recede in the winter, a typical acre of salt marsh produces about 50 pounds of little bitty fish a year that get exported to the adjacent estuary for all of the rest of the transient species that live further out to graze on. So there's this huge subsidy from a salt marsh that's not necessarily the big fish that you're trying to catch, but those big fish depend on that production. And this is some of the justification that we used when we were developing the plans to go back in and either reconnect impoundments or do restoration on some of these other wetland impacts. So this is just one of the things Bob was talking about. Coastal wetlands are highly productive systems. They have one of the highest productivities of any habitat type. And they provide food for all kinds of things. We talked about the transients that come in and forage. The transients also come in as very small juveniles, and they spend part of their life history within the wetland using it as a nursery habitat. So this is where the babies feed on the little organisms that are fed or growing inside those wetland systems. So that nursery function is critical. Again, we're not talking about the big fish. We're talking about the babies of the big fish. If you still want to catch those big fish later on, you need the wetland as a nursery. The next group of these are things that most people didn't think about when they first looked at whether they were going to impact a salt marsh or not. There's been a extensive work done recently looking at the role of coastal wetlands in protecting adjacent upland resources. Storm surge, wave energy that gets dampened by coastal wetland systems. So they did this by, what do they call it? What's the term they use? Impact avoidance. So they looked at areas that were damaged and they looked at areas that had hurricane impacts, and they compared the relationship between how much area of salt marsh there was versus where there wasn't salt marsh, and looked at what the costs to those storms was. And they come up with a number, and they're squishy numbers, but they look in enough places and you get fairly comfortable with the median value for some of those. Coastal wetlands, particularly mangroves, do a really good job at breaking wave energy, which also protects the marsh itself or the wetland itself from erosion. As those wetland systems are inundated during the fall or during high tides where they're, low marsh areas that inundate on every tide cycle, the water slows down and all of the plants slow the movement of water to allow settling to occur. So a lot of the particulate matter that's in the water column ends up being deposited in the marsh, and the water that comes back off the marsh is cleaner. Those plants also use nutrients. That's how they grow. Those nutrients are incorporated into the plant matter, and they can be sequestered in those soils that are being built by those plants. Salt marshes are one of the few habitats that actually grow vertically on their own. So by trapping particulates or producing organic matter, salt marshes get higher on their own. If it's working right, they will get higher. The question is, can they get higher fast enough? And that's where we're having issues right now. So along that same line, the way those nutrients are sequestered and those particles are sequestered is with the carbon that's produced by the plants. So the stems and the roots and the leaves that all are incorporated into the soils, it sequesters carbon. So plants take in carbon dioxide, they produce plant matter. That plant matter in this system is buried in the soils and it's held there. So one of the highest rates of carbon sequestration for a habitat is in coastal wetlands. They bury a huge amount of carbon. And I'm sort of strange, but I really like walking around in salt marshes. Some people think I'm nuts, but I like that. Some people don't like getting their feet wet or muddy, and I'm there in a heartbeat whenever we get a chance. I spend too much time sitting behind a computer terminal these days and would much prefer spending more time out. So this last item is what we were just talking about. If you have a fully functional, so read restored or unimpacted, but a fully functional coastal wetland, they build elevation, which enhances their resilience. So they're much more likely to be able to resist the effects of sea level rise if they're fully functional, if they're not impacted by things that we've done historically. So what does that actually mean? Okay, so here we get into the squishy numbers. There's a couple published studies that looked at all different kinds of habitats, how much carbon they sequester, what the services for storm dampening and all of that are. And this relatively astounding number is the annual services per acre for a coastal wetland system. So if you had, well, we'll go on to the next one because it gets even more interesting. So we acquire wetlands because some wetlands that are in private hands, they won't let us do restoration. So we've paid anywhere from a couple of $1,000s to maybe $7,000 or $8,000, $10,000 at the outside for a coastal wetland, for the wetland part. Obviously, if there's upland adjacent to it, the value of the parcel you may acquire may be more than that. But the value assigned to the wetlands, $10,000 is an overestimate, even now. The most expensive restoration activity we've done was that intercoastal waterway dredge spoil where they piled the dirt up. We excavated all that dirt, loaded it onto trucks, they hauled it away, and we ended up with salt marsh when we were done. And that was about 28 to say 32,000 an acre for we did that work over about an 8 or 9 year period. So from the beginning, it was a little cheaper. At the end, it was a little more expensive. So put those two together, $50,000 to buy and restore an acre of salt marsh. Even if this number is inflated, let's say it's only $50,000 rather than 78. We spent $50,000 to buy and restore. So while our restored wetlands take a few years to get fully functional, it doesn't take long before we're in the black for any of this restoration activity we do. And this is not the value to the landowner. This is the value to the community. The landowner's not the only guy that fishes there. The landowner's not the only guy that lives nearby. You know, there's a lot of things in those values that benefit broader groups. So we didn't have all those numbers when we started, but I'm going to go through a couple of examples of how we did some of this restoration work. Remember the little map with all the little blue spoil piles? That's some of these. This is in North Peninsula State Park, the northern end of Volusia County. This area right here is this area right here. This piece down here is this area right here. We basically excavated all the material to the center, maintained a road, and hauled the material away. It actually, we got a lot more acreage completed, even though it ended up still being about $30,000 an acre, because we didn't pay anybody to haul that material away. The contractor we used knew people who were doing development and work all over the place. They came and we just loaded their truck and they drove away, and we didn't have to pay for anything other than the loading. We worked with Flagler County. Flagler County came down and got, I don't know, 14,000 yards of material because they had a need for fill material and we were excavating material. We partnered, this was funded through the Obama era Recovery Act. So this was whatever the title of that thing was, but it was one of the stimulus programs. And this was a project that was funded through NOAA. And we hooked up with another Recovery Act project that was building an overpass on Interstate 95 in Volusia County. And we got rid of about 40,000 cubic yards of material that went from our restoration activities to a road building project. And they didn't have to pay for fill. They just had to pay the trucks to come and get it. We've done, well, little bit pictures about what we do. Basically, you have to clear all the upland vegetation off. We mounded the material up, loaded it on over the road trucks, hauled it away. We got close to the marsh elevation and then do the final grading. We do planting. We plant smooth cordgrass, Spartina alterniflora. It's one of the most common salt marsh plants, we'll say north of here, north of Florida. There's a lot of Spartina in Florida, but mangroves, particularly red mangroves, are in that same sort of area. But the nurseries that provide plants for restoration activities and for other kinds of work, mitigation and those kinds of things, have alterniflora in abundance. We planted at nowhere near the density you would plant if you were actually doing mitigation, because we weren't trying to do that. We're not doing mitigation. We planted, and this is a little dense, I'm not sure where this one was, but we plant on 4 to 5 foot centers. I mean, typically you would plant on 18-inch centers. So if you have an area, what's the distance between the plants to the next plant? big open space between the plants we planted because we weren't worried about it being Spartina alterniflora. All we were trying to do was make that surface rough so that when the mangrove propagule floated by at high water, it ran into something and settled there, where the saltwort and glasswort seeds are bopping along in the water. They would run into something and be trapped. If fragments of plants get trapped, sometimes they'll root. Our goal was to make that surface rough so that things would be trapped, because we're not trying to grow Spartina marshes. We're trying to create a coastal wetland, and they sort themselves out based on the flood inundation and the elevations. So this is an area, same kind of area. From here to where that water tower is, this is in southern Flagler Beach. There's a water tower right at Gamble Rogers State Park. So this is in Volusia County. This was all spoil. And this is about 3 or 4 years after restoration. So you can still see the alterniflora on the edge, but there's black mangroves all over the place. There's a mix of Baetis and Salicornia in there. So this is the last piece we did. This is all the work we did in North Peninsula State Park. We started, these were the two that I showed you the initial work on. This was in the initial phase. Then we went down south. This is High Bridge Road. If you know where High Bridge Road is, there's some really cool, that road has a canopy of live oaks over it as you get to it. It's really a nice drive. It also goes underwater when tides are really high, but this was all dredge spoil along the intercoastal. And we had done all of this work except for this little patch, this piece right down here. And that's the last piece we did. There's a interesting story there, and if we have time, we can talk about it later. So this is about 100 acres of salt marsh. This took us from 2009 to about 2020 to do all of the pieces, 2018 to do all of the pieces. No, 2020. So we spent, I don't know what the total amount is, but if you take that 78,000 and multiply it by 100 acres, that's $7.8 million annually in services provided. And we spent $3 million doing the restoration. So this is an example of dragline ditching. This is in Flagler County. So you can see these ditch systems and the spoil piles around them. This one isn't ditched quite as densely as some of the stuff in the initial slides I showed you. There's not parallel rows of ditches. This is sort of an uneven environment, so the goal was a little different. So there's little pieces of upland, and there's little high spots, and there's little sloughs. So the ditch system was more or less designed for the area that's there. This is the broader perspective on it. This is the turning basin where the boat ramp is at Gamble Rogers State Park. So that's the area we're working in. And there's about 96 acres of outlined in orange there. So here's the example. These are the spoil piles. You can see them. And they go around the edge of all of this. You can actually see they started working there. This is in June of 2019. Basically, we set a target elevation based on the plant communities in the adjacent areas. So we looked at what was there and where those elevations occurred. We were looking for the upper part of the intertidal zone where it was just at its transition to upland community. So we want to set it as high as we can without creating habitat that's going to attract exotic species. And this allows those wetland areas to recover and vegetate before they're struggling to keep up with sea level rise. So we give them as much advantage as we can and still keep them in the wetland category. So here's 2019 in September. So it's all done. It actually got finished. This section got finished in August, but this is shortly after. So there's not much here. There are plants on that surface. You can still see where the spoil piles were. And in many cases where the spoil piles were, there's vegetation around. Where the slope went down and we cut it off and filled, vegetation would pop back up in that area that was right at that transition. So this is in March of 2021. So this is about 16 months after. And you can see that there's actually quite a bit of vegetation on that surface. This is a year later. And this is something we found in a lot of the restoration we're doing. So a year, you get some vegetation. 2 years, it's okay. By the time you get to 2.5 to 3 years, things really come back. So it takes some time for it to get to where, this is a year later from this. And on the ground, it looks like this. Nothing was planted here. So this wasn't even Spartina. This was just a scraped, flat, unvegetated surface. So the sort, whoops, wow. One more. So the sort of yellowish is saltwort. It's one of the marsh succulents. It's almost like a cactusy kind of plant. They actually call it pickleweed is one of the other names for it. It is extremely salty, and it actually was used in pickling vegetables because it's really salty. Some people put this stuff on their salads. It's sort of, I don't know that I would go out of my way for betas, but so there are a couple of those kinds of plants that are marsh succulents. But if you look carefully, you can see small mangroves starting. So this is where the edge of the undisturbed marsh is. And all of this was spoil pile or the little ditches in between that we filled. So this is all the restored surface. So longer look, this is stuff we did in Mosquito Lagoon. So if you picture Edgewater and Oak Hill, this is sort of just at the south end of Edgewater. This is when we were scraping the material down. Again, these circular areas were the spoil piles, and the area in between them were little side ditches that we filled. So you get the surface of the spoil pile plus the additional area filled. So like here, all of this additional area is returned to a wetland elevation. And this is what it looks like 10 years later. It has a healthy mangrove fringe. There's still areas that have the marsh succulent vegetation in them in a mix. That's the kind of work we've been doing. And I think, yeah, we've done about 800 acres, which returned about, so the 800 acres is the line around the disturbed area, which includes water and things that we didn't and can't restore, and any existing marsh. We returned out of this 800 acres about 40%, 50% of it. I think the total, and I don't think I can see the number, is close to 300 acres that were returned to wetland elevation. And this is, I think, our average project acre, so this 800 acres, is about $4,500 an acre for the restoration. So it's maybe $15,000 or $16,000 per acre return to salt marsh. So substantially less expensive than the dredge spoil removal. Back to impoundments. So there's a couple ways that we dealt with impoundments. Impoundments were built for mosquito control. If we just took down the dikes in most places, the people living next door would not be very happy. So one of the considerations was that rather than leaving them completely isolated without being connected to the estuary, we installed culverts around the perimeter, connecting the estuary to the interior of the impoundment. And that's what I was doing at Harbor Branch. We were looking and counting the fish, going back and forth to make sure that all of the species of fish would utilize the culverts that were being placed. We looked at the kinds of water control structures, because what we ended up with is a thing called rotational impoundment management. During that hot, rainy summer season, when the mosquitoes come off and can get through their life history stages in really short periods, the mosquito control districts close the culverts, pump water into them, and they keep them closed, and it eliminates that whole area. They call it source reduction. It eliminates that whole area from breeding mosquitoes. But when that fall water level comes up and inundates that marsh, we can open those culverts, and they can stay open until the following summer when they need to be closed again for mosquito control. What we looked at is whether the nursery functions were provided with that kind of timing. And the vast majority of the fish species recruited in during that high water period after they were opened. Snook come in huge numbers after that high water period when the impoundments would be open. But not all of those impoundments still need to be impoundments. A lot of the work that was done at Kennedy Space Center, they had at one point 7 drag lines working. NASA was a little nervous about their engineers being consumed by mosquitoes while they were trying to launch rockets, and it was impacting flight operations. So they funded Brevard Mosquito Control, and they bought and operated 7 drag lines for basically from 63 to 69 or 70, and basically impounded everything. But what that meant was there were a lot of places where they dug a ditch and built a road for the excavator to keep working along a shoreline, even though there wasn't much marsh there, because there was a lot of marsh here and there's a lot of marsh up there, and the easiest way to get the equipment there is just to build along. So we had a lot of impoundments that were pretty narrow. So some of those we can actually restore. We also played around with breaching of impoundments. I don't like it. We did it. There's still some breached impoundments out there, but the dike that remains still has exotics and upland species on it, and they're a mess to maintain. If you're going to try and control exotics in an area, it's a constant effort. If you restore that dike and it gets down to salt marsh elevation, Brazilian peppers, Australian pines, the vast majority of the exotics that we have problems with don't survive. So, all of the stuff that's in yellow, we put culverts in, or somebody put culverts in. The stuff that's in red, and this is personal for me, I think need more culverts. Not necessarily a district position, not necessarily other agencies agree, but this is my map, so I keep track that way. There are some areas here, like these gray areas, that we're really not interested in reconnecting. They launch rockets right here, and it's probably not a good idea to have them open when they launch rockets right next door. But what you do see there are some green areas. Oh, sorry. This is the breakdown of the nearly 40,000 acres. So breached, connected as culverts, restored, and my target, which most of which we'll never get anyway, because it just won't. So if you want to restore this wetland, basically you just put the dirt back in the ditch. Now, funny thing, there's never enough material to completely fill that ditch. And there's a couple of good reasons for that. So once you pile up the dirt, so this is all of that organic matter that's been accumulating in those soils, and you mound them up above tide where they dry out, it all oxidizes. All the organic matter just oxidizes away. So what you're putting back is a lot more of the inorganic materials, the sands and clays and stuff. So there's less. The other thing that's happened is since the 60s, late 50s, 60s into the early 70s, when these were built, there's been 4 to 6 inches of sea level rise. So not enough. We leave this section of ditch and we connect it back to the estuary so that it's not just an isolated pool. Again, we use the plant community to set our elevation and leave the vegetated shoreline, excavate a bench, what we call the bench, that's at the target elevation behind it, and then use large, like bulldozers and such, to move the material to the borrow ditch on the interior. And then we use a long reach excavator to do the final grade. So it just pulls across from our edge into the interior. And this is the remnant piece of ditch that's left. And the other thing we do is we leave deeper areas where there's interior water features. So for example, this one up here, the impoundment went around and there's this big open water in the interior. We left a deep, wide opening to reconnect those water features. And even on a small scale, that's what we do. If there's areas where there's a small drainage on the interior or a low area, we'll connect it to the estuary. We've done about 43 miles of dike, 6.25 acres per mile is the average. So 250 acres, something like that. Is that about right, Bob? Doing a calculation in your head? The other thing that happens in some impoundments is the management has eliminated vegetation for so long that the interior erodes and redistributes that organic matter. In this case, pretty specific case, it has this big 35-acre pond in the middle of it. When you kill all the vegetation, all of this organic matter just sort of gets sloshed around by storms and such, and a lot of it deposited in that marsh, which means this whole surface is now too low to support emergent vegetation. It's open water. And we actually did a project where we were trying to bring those surfaces back up. The Corps of Engineers is trying to develop methods and partner with people to use dredge material for a beneficial use, like reestablishing these wetland areas at an elevation that'll support emergent vegetation. Now, I gave you all of those methods. This is a project we've been playing with. We've been trying to buy this from Frank Ford for what, 25 years? This is an area, again, in northern Volusia County. This is Bulow Creek State Park from their unit management plan. And that little area in sort of reddish color is their optimum park boundary. So what that means is if they can, they would like to own this because it'll make managing the whole park easier. It's privately owned. So all of these dark cross-hatched are private owners. We've approached them. We have willing sellers for many of them. We've applied for grant funding to purchase them. Now, why would we want to do that? Well, this particular marsh has been dragline ditched. It has intercoastal waterway dredge. It's been managed as an impoundment, so it has impoundment dikes, and a large area of the interior is subsided to where it doesn't support emergent vegetation again. So all of the things that I just talked about could be implemented at this site if we require it. And to just verify that this was what it was, this is the northeast corner of that area in 1951. The only impacts at this point were the road. This is High Bridge Road. This is in North Peninsula State Park. The Intracoastal Waterway and its dredge spoil. And that's pretty much all that was there then. 1958, first, they realigned the bridge. I think the current bridge that was there was built in the late 50s. You can see the dragline ditch, the first iteration of dragline ditching. You can see some new intercoastal waterway dredge spoil deposited. This is 1969. They added more dragline ditching. They built the impoundment, and this is the first and only image I have of the impoundment with water in it. This dark color is water. They also ditched all of this up here. This area near Bulow Creek, so this is Bulow Creek, this is the natural marsh community, and we'll look at that as we keep going here. So this is in 1976. This is that same impoundment, but it doesn't have water in it anymore. It also doesn't have vegetation anymore. All of the vegetation is gone. And there's a little more dragline ditching. And a guy built a house on that spoil pile. 1999. I put this one up there to accentuate how much open water there is where this all used to be marsh. And the dragline ditching and the dredge spoil. This is North Peninsula State Park, and we'll see that in a minute. So this is 2017. The impoundment has breached. We've done dragline ditch restoration up here. We've done intercoastal waterway dredge spoil removal along here. And this is all open water. So we have the dikes, we have the dredge spoil, we have the dragline ditches, and we have the subsided marsh. And if we can buy it, this will be, it's going to take longer than I have left at the Water Management District, but it will be what I try and get set up and moving before. This site has 7 miles of dike, 200 acres of dragline ditching, 20 acres of dredge spoil, and over 500 acres that have subsided. So if we can just bend the curve on this and get some of that back, that's the goal. And that's me. You guys will put this, is the presentation going to be available? This link, if you're interested, is what's called a story map. We did it a year or so ago. It talks about a lot of the stuff that I just presented in map form. It has projects we've completed, projects we're kicking around doing, and disturbed areas throughout the coastal areas of the Water Management District. It's an interesting thing. Question? That was a little longer than.
Questions from the audience?
Thank you for a wonderful presentation. I was very interested myself in how you monetized the worth of doing the wetland restoration, but my question has to do with what you think the biggest challenge is in persuading state legislators or the governor's office to dedicate money for these kinds of projects for perhaps matching funds that are available from the federal government or nonprofits?
As strange as it seems, there is more money sloshing around right now to do projects than there has been in a decade or more. It's actually probably why I'm still working, because I actually get to do stuff I really like to do, and there's money available to do it. To the point specifically, there are DEP runs a system of portals for funding projects. There's money for water quality in the Indian River Lagoon. There's money for resilience. There's a wetland category now. I got 2 projects funded this past year. It freed up money that I had in my budget so I could actually do 3 projects, and those were just little ones. We also submitted with the Indian River Lagoon National Estuary Program to one of the NOAA programs, the fisheries habitat programs, which funded a lot of the dredge spoil removal work we had done previously. And some of the dike removal work was funded by NOAA. It's looking good for the project we submitted with the National Estuary Program. And I still have another project, actually 2 more projects, including the Tomoka impoundment. We submitted to a NOAA funding source with it's called the South Atlantic Salt Marsh Initiative. So it's a multi-state, multi-agency group that put together a grant proposal, and we put in money to acquire that. So I have 2 NOAA funded restoration projects still pending, a NOAA funded acquisition project, and 3 state and district funded projects all going on at the same time. I actually need like 2 of me at this point, which has not been the case in a while.
My work on coastal salt marshes is so ancient that I hate to say this in South Florida, but at that point, we were doing some restoration, but a lot of it was, what we were looking at was mitigation from developers, and they would supposedly, and I do mean supposedly, mitigate, so many mangroves and so, and they were abominable. How's it going, and do they still do that stuff?
So
I'm on freshwater stuff.
the track record was really poor at the beginning. It has gotten some better. There are also, and I have mixed feelings about it, but they have mitigation banks that actually require appropriate function before they give credits. I would much prefer to do the restoration myself, but it is some better than it was. There are better criteria for success these days, and they do watch. I would agree with that.
Ron, how does your monetized study compare with the one that I think it was Eugene, it might have been HT Odom, did many years ago on the wetlands?
I don't know specifically
Yeah.
what the comparison is. The one I used when I started when Bob hired me, there was a Fred Bell publication
Okay.
that had, I don't know, East Coast wetlands were like $10,000 an acre, but that was an asset value. So that was what they valued the wetland at. And that was just for fisheries. So I don't know. These are much larger. Costanza's been doing ecosystem valuations probably 10 or 15 years. and Bill Mitch did the sort of summary document that I cited on this one. A lot of that's 2015-ish, 2018-ish. They used $2007, so there's, I mean, it's actually more than that now. It would be higher if you did an adjustment for inflation.
Okay, and when I was on the Fishery Advisory Council, they had stated that 80% of the game fish spend all or part of their juvenile or early life in the mangrove salt marsh.
Yep.
That's still a good
I-
figure?
I wouldn't argue with the figure. No, we've seen, I mean, the work we did when I worked down at Harbor Branch, I mean, most of the stuff that moves in and out is a commercial or recreational species.
Yeah.
The stuff that stays inside is, you know, mostly the residents. There's some smaller stuff, medium-sized stuff that moves back and forth, but the vast majority of the game fish spend time in the system.
Just one comment. If you want to know about the St. Lucie County impoundments, talk to
spread.
my husband. He was the mosquito control director there for a number of years.
I worked with
And-
his successors.
By the way, Pat Hardin was on the St. Johns River Water Management District Governing Board during what times when both Ron and I were there.
A program is you described and its success. Just to remind me of the reasons I'm generally happy to pay taxes, which pay for all of this. Sometimes we forget that.
Nothing's free. Sir, you had a question earlier?
Yeah, thank you, Ron. I had a question as to whether Nature Conservancy has any role to play with this kind of restoration.
We've worked closely with the Nature Conservancy. Yeah. The Northeast Florida Estuarine Restoration Team, which is one of the interagency groups we worked on, the not-for-profit slot in that group is the Nature Conservancy. They did a lot of work in Mosquito Lagoon on oysters. Ann Birch, who's, forget what her title is, marine programs for the state of Florida. She retires in August. I'm not happy about that, but they were involved in a lot of the stuff. They focused recently much more in the oyster and shoreline stabilization kinds of things.
Thank you.
No other questions? Thank you, Ron. And Ron is willing to hang around
hang
for a
around
bit
for a
if
while.
there are more questions. Thank you.
Thank you.